Hi everyone, this video is going to cover the Math 124 note outline for section 2.2, which is the algebra of functions. So we've been talking about functions, and the notation that we've learned about looks like that, like f of x or g of x or h of x and that type of thing. And in this section, instead of just kind of dealing with one function at a time, we're going to have two functions and we're going to combine those two functions in different ways. Maybe we can take two functions and add them together, or subtract them, or multiply them, or divide them. So that's what this box is saying right here, is that we have sums, differences, products, and quotients. And of course, sums means we're adding, differences is subtract, products is multiplication, and quotients is basically division. And it says if f and g are functions, so we have two functions, one's f of x, one's g of x. And then if x is in the domain of each function, then we have these rules down here. But these rules are pretty self-explanatory. So if you look at this first one, it says f plus g of x. It's saying if you see that, all it means is take the f of x function and add it to the g of x function because there's a plus in between them. Same kind of thing with the next one. If you have f minus g of x, all that's telling you to do is subtract f of x minus g of x. And then when they're written like that, right next to each other, fg of x, that just means that you take the f of x function and multiply it by the g of x function. And then the last one, if you have f slash g, that means f over g of x. So that is just when you take the f of x function and you put it over the g of x function, provided that g of x does not equal 0. And of course, we know all about that because the g of x in this case is going to be the denominator. And we know from all our talk of domain previously that the denominator cannot ever equal 0. So we're making sure that g of x is not equal to 0 if we're trying to do the quotient of the two functions. And then one other thing that I want to put in this box that you should as well, it's something that is more a helpful reminder, and it's something that if you do it, you're less likely to make a mistake on these. And it has to do with this subtraction part here. I suggest that if you're ever doing a subtraction of two functions, that when you write the second function down, this g of x part over here, put parentheses around that function when you're writing it. Put parentheses there. And when we do some examples, I will do that in the examples as well. So here are some examples. We have 4 different functions here. We got f of x equals -1 over x, g of x is equal to x squared minus 2, h of x is equal to root 10 plus x, and k of x equals x plus 2. And we're just going to take some of these functions and maybe add them together or subtract them or multiply them or divide them. So part A says f minus g of x. So since there's the minus there, we literally just write f of x minus g of x. And be careful though, this is what I was just talking about with the parentheses. We're going to put parentheses around the g of x. So when I go to write that, we're just going to replace f of x with what it is. So what is f of x here? Go back, look over here. It says f of x equals -1 over x. So I'm going to replace this f of x with that, -1 over x, minus, and then I'm going to put parentheses, don't forget that. Then we have the g of x function, and what's the g of x function here? That's right here. G of x is equal to x squared minus 2. So I'm going to put that inside the parentheses, like that. And then the last step See the minus right here? This is why we're putting the parentheses, is to indicate that we need to distribute this minus to every term in the g of x function. So we start with the negative 1 over x, and then we have minus x squared, so distribute that, minus x squared. And then this is where it gets really important to distribute this minus. So we distribute the minus to this negative 2. We get a minus times a negative, which gives us a positive 2. And if we didn't put those parentheses, then it wouldn't change to the plus 2 here like it's supposed to, okay? And we can't simplify anymore because these are not like terms. So we're done with that one. All right, so now let's go to part B. Compare part A to part B. What's the only difference that's happening between parts A and B? Well, part B, instead of having an x here, that x is being replaced with a 2. So instead of f of x minus g of x, we're going to do f of 2 minus g of 2. And we all know what that means. So if we just focus here, what's f of 2? How do we find that? We would just plug the 2 into the f function. So let's go back and look what f of x is. So we're going to replace this x here with 2. So we're going to get negative 1 over 2 minus, now we're going to do g of 2. Let's look back at the g function. If we plug 2 into the g function, g of 2 is going to equal 2 squared minus 2, which is 4 minus 2, which is 2. So I'm going to put 2 here. And then we have to just simplify this, which is just basically fraction work. We need the same denominator because they are being subtracted. So I'm going to change this 2 into 4 over 2 so that they have the same denominator. That way we can subtract. So negative 1 minus 4 is negative 5 on top over 2. So this is what I'm going to call option 1. But we also have an option 2 to handle this particular example. We could just plug 2 into the function that we got up there. And that would also work, but sometimes I do it this way and sometimes I would do this other option. But this second option only works if you already did part A. Sometimes we don't have this done yet, in which case I would just do option 1. So either option is fine. So let's go on to part C. Gk of x. So they're right next to each other, so they're being multiplied, g times k. So that's what I'm going to write first. Write the first function, g of x, times the second function, k of x. And then we're just going to replace the g of x with what that is, and we're going to replace k of x with what that is. So let's go back and look. G of x is equal to x squared minus 2. And we're multiplying, so I'm going to put that in parentheses, times the k of x, which is x plus 2. So I'm going to put that in parentheses to show that we are multiplying these two together. And then we have a binomial times a binomial, so I'm going to FOIL it out. I'm going to get x cubed plus 2x squared minus 2x minus 4 if I do that. And then at that point, I would try to combine like terms, but there aren't any like terms here, so we would be done. And then part D, it's gk of 3. So that means we're going to multiply the two functions, but instead of having x's here and here, we're going to have 3's. So this means take g of 3 and multiply it by k of 3. So let's find out what g of 3 is. G of 3 means plug 3 into this function. So I have 3 squared minus 2, so 9 minus 2, which is 7. We got 7 times, and then k of 3, we would plug 3 in right there. So 3 plus 2 is 5. So times 5, and of course that's just 35. And again, this is option 1. And option 2 is that we would just plug 3 into that function that we got in part C and then simplify. But it's the same type of thing. If you don't have this function written out in front of you yet, then you might as well just go with option 1. It might be a little bit easier and less work. Okay, but again, either option that you choose is fine. Part E, we have h over g of x. So to write that, we're going to put h of x on top over g of x. So let's go look to see what those two functions are. H of x is the root 10 plus x, and the g of x is the x squared minus 2. So this is going to go in the numerator, and this is going to go in the denominator. So I get root 10 plus x on top over x squared minus 2 on the bottom, and there's no simplifying to be done there, so that would be our answer. All right, part F, we have h over g of negative 15. So the only difference between E and F is that instead of x's, we're going to replace the x's with negative 15. And I'm actually going to do this by using option 2 this time. Option 2, which is plug negative 15 into what we got for part E. So I'm going to plug negative 15 in right here, and I'm going to plug it in right there and then simplify and see what happens. I get root 10 plus negative 15 over parentheses negative 15, close them, squared minus 2. So we're just replacing these x's with negative 15. I'm going to simplify. So on the top, what do we get? We have 10 plus negative 15. What's that? That's negative 5 over, in the bottom we have negative 15 squared. That's going to give you 225. If you subtract 2, you're going to get 223. Now look at what we've written down. Is there anything that should jump out at us here? There is. This is bad. Why is this bad? We know that at this point in the class, we are not allowed to have negatives inside even roots, and that's exactly what we have right here. This is a domain issue that we're not allowed to have, so since we can't have that, for our answer, we were trying to find this. This was the original question. So we're just going to say that this is not a real number. And basically, the reason why that happened is because we tried to plug in negative 15. And if you go back up and look at h of x, using what we've learned about domain in previous sections, if you found the domain of this function right here, the h of x function, you'll find that negative 15 is not in the domain of h of x. So that's why it's not going to be in the domain of h over g of x either. All right, so speaking of domain, that brings us to the next page. So far on page 1, all we did was we took two functions and combined them somehow, either adding or subtracting or multiplying or dividing them. Now, instead of doing just that, we're actually going to find the domain of these combinations of functions. So in previous sections, we talked about finding the domain of certain functions, and now we're going to apply that here, and these are going to be a little bit more complicated, but we're still going to apply what we learned back then to these newer types of functions. So if you look, we have that we're going to talk about the domain of f plus g, and also f minus g, and f times g. And then I'm going to talk about this other one in a little bit, but for these, we have this statement here. So these two go together. So let's read what it says. If f and g are functions, then the domain of the functions f plus g, f minus g, and f times g is the intersection of the domain of f and the domain of g. Basically what that is saying is that if you want to find the domain of these three types here, what you're going to do is you're going to find the domain of f on its own, and you're going to find the domain of g on its own, and then you're just going to say, well, what do those two domains have in common? And that will be your answer. But for this one, this is going to work a little bit differently. You'll still start the same, but there will be one extra step at the end, which is make sure that the denominator, g of x, cannot equal 0. The other three, we don't have denominators there, so that's not an issue. But we know that when we have a denominator, that can create a domain issue. So we're going to have to address that at the end when we do that type of domain. All right, so let's just do some examples to get an idea of what we are talking about here. So here we have 5 functions, and below it says find the domain of the following. So another thing to just note is make sure you're actually following the directions. Sometimes it's just asking you to find f minus g of x, so you would just find f minus g of x like we did on the first page. But these are different. They're not saying just find this, they're saying find the domain of this function. And then we're going to find the domain of this function, and we're going to find the domain of this function, and this one, and yeah. So before we even begin, I'm actually going to find the domain of all of these 5 functions individually before we get into it, because we're going to need to do that anyway. And it will be a good refresher for how to find domain in general. So let's start with f of x equals -1 over x. So remember from previous sections, we always look for 2 possible domain issues. We look for denominators and we look for even roots. So does f of x have a denominator? Yeah, it definitely has a denominator right there. X is the denominator. Does it have any even roots? Nope. So we have to worry about that denominator, and we always take the denominator and set it not equal to 0. And then we can write it in interval notation if we want that, but this is the domain for that one. How about g of x? We ask ourselves the same 2 questions. Do we have a denominator here? Nope. Do we have even roots here? Nope. So that's the nice case. When you do not have any of those possible 2 domain issues, you just say, okay, I'm done, -∞ to infinity. So that's that one. How about h of x? Do we have any denominators here? No denominators. Do we have any even roots? Yes, it's literally an even root. So to handle even roots, you take the inside of the even root, 10 plus x, and you set it greater than or equal to 0 because it can't be negative. Subtract the 10 over, and then we can write that in interval notation. X is greater than or equal to -10, so that's bracket -10, comma, infinity. And then for k of x and t of x, what are those domains? This should be pretty fast because you say, okay, do these have denominators? Nope. Do these have even roots? Nope. So domain for both of them is negative infinity to infinity. So we're going to keep these in mind for later. We haven't even started doing the actual problem yet. We're just preparing to do these next exercises. Because finding the domains like we just did of each function individually is going to make the examples that we're about to do go much more quickly. All right, so find the domain of the following. So we have f minus g of x. So all we're going to do is we're going to write the domain of each of them, domain of f of x. We're going to write the domain of g of x. And we already did that up here. So f of x was negative infinity to 0, skip over 0, keep going to infinity. For g of x, it was negative infinity to infinity. Then what we're going to do is draw these on a number line. We're going to draw each of them on their own number line. So the easier one is this negative infinity to infinity. That just means like literally shade the entire number line. And then for the domain of f of x, we'll shade the entire number line, but we'll leave out the number 0. So at 0, we're going to have an open circle, but we're going to shade everywhere else. And then once you've done that, you ask yourself this question. What do these have in common? So you just compare these two number lines and basically say, where are they both shaded at the same time? Well, this one's shaded here, skips over 0, keeps going forever. This one's shaded everywhere. So the parts that they have shaded in common are everywhere except 0. So they have everything from negative infinity up to 0, skip over 0, keep going to infinity. That's what they have in common. So that's going to be our answer for the domain of the whole f minus g of x. That's the domain for that. Well, let's do another one. gk of x. We're going to do the exact same thing if we're finding the domain. So we're going to write domain of g of x. And if you look back at the top, we said that was negative infinity to infinity. Then we write the domain of k of x. At the top, if you look, it says that that is negative infinity to infinity as well. So we're going to draw both of them on a number line, but they're just both all shaded because it's negative infinity to infinity. And once again, we just ask, what do these have in common? But literally, they're the exact same thing. They're both shaded everywhere. So that's what they have in common. They have everything from negative infinity shaded up to infinity. So we're gk of x. That is the domain there. All right, so let's keep going and go on to the next page. It's still continued from page 2, so we're still just finding domain. Remember, you always want to keep the directions in mind. What am I actually trying to do right now? And here we're still just trying to find the domain. And so we're going to do the same thing as before. We're going to write what the domain of f of x is. And we're going to write what the domain of h of x is. And if we look back to the previous page, we said that the domain of f of x is negative infinity up to 0, skip over 0, keep going to infinity. And we said that the domain of h of x is negative 10 up to infinity. And then we're going to draw each of these on the number line. So remember, for this first one, we have an open circle at 0 and everything else is shaded. And then for the second one, we want to start at negative 10 and shade everything to the right up to infinity. So negative 10, maybe we'll just put over here. It's a bracket, so we have a closed circle at negative 10, and then shade everything to the right. And we're going to ask ourselves that same question. What do these have in common? Another way to phrase that is, where are they overlapping, or where are they both shaded on the number line? And I like to think of this one as, I think about, let's start far left, so negative infinity. The top one is shaded from negative infinity up to here, but the bottom one's not. So if you start from the left and move your way right, you can just say, well, where do we start having something in common? And that's here. Right when you hit negative 10, that's where they both start having something shaded. So we'll start at negative 10, comma, up to where? So keep going from negative 10. They both have this part shaded, they both have this part shaded, but then once we hit 0, this has 0 open and this part has 0 closed. So they do not have 0 in common. So we're going to skip over 0. And then from 0 on to the right, forever, they're both shaded. So they're both shaded from 0, comma, up to infinity. That's what they have in common, and that is our answer for the domain of f times h of x. All right, let's do one more here. T over k of x. Now this, we're going to have alarm bells go off, okay? Why? Why is this one going to be a little bit different than the other ones we just did? It's because this one has a denominator, right? So this is t of x over k of x. We have a denominator. And before we do the domain, I'm just going to practice figuring out what this is. So right now, I'm actually not doing the domain part. I'm just simplifying what t of x over k of x is. So if you look back on the previous page and you look for t of x is equal to x squared minus 4 over, and if you look at k of x is equal to x plus 2. And then we simplify. Well, one way to simplify this is we would factor the numerator, and we know how to do that, right? Because this is difference of squares. So what's the numerator factor out to? That should be x plus 2 times x minus 2, and then over our denominator, which is x plus 2. And then we have the same factor on the top and the bottom, so these can cancel. So really we get x minus 2. And so this part that we just did, this is just for practice. This is, again, not part of domain. Not part of finding domain. So I'm going to come back to that actually in a few minutes, but let's go and actually do what we're supposed to be doing here, which is finding the domain of this. So we're going to start off the same. We're going to find the domain of t of x, and we're going to find the domain of k of x. But we already did that on the previous page, so just go look back. For a domain of t of x, it was negative infinity to infinity, and it was also negative infinity to infinity for k of x. So when we put these on the number line, they're completely shaded everywhere. We still ask ourselves, what do these have in common? And they're both shaded from negative infinity to infinity, so that's what they have in common. Now, wait, not done yet. One more step. Normally, we would be done here and we would just box it and that would be our answer. But because we have a denominator, we have to handle the denominator. So let's see what that one more step is. So what do we need to do? We have a denominator here and we know that we are not allowed to have a denominator of 0. So let's find out when that denominator will equal 0. So we're going to determine when the denominator, which is k of x, equals 0. That's our denominator. And what is k of x? If you look back, k of x was equal to x plus 2. So we want to know, when does x plus 2 equal 0? Well, we subtract the 2 and we get that. So when x equals negative 2, that's when our denominator will be 0, and that would be a bad thing. So we don't want x to equal negative 2. So we're going to take this and we're going to leave this value out of what we got right here. We had negative infinity up to infinity before, so we're going to keep that the same, but we have to leave negative 2 out of that interval. So to do that, it's going to look like negative infinity up to negative 2, but skip over negative 2 and then keep going to infinity. That's going to be our final answer for our domain of t over k of x. So this last part here that we just did, part D, make sure that you are doing that one extra step if you have the denominator situation going on. All right, so now let's go on to the last page. The top of page 3 is an extremely important part of this course. So one of the most important parts of this course is domain. That's why I try to stress it a lot. Domain is probably in the top 3 most important concepts of this course. And this next part that we're going to talk about, the difference quotient, is probably pretty up there too, especially because sometimes people struggle a little bit like getting used to it. But if you practice it enough times and you kind of follow the steps that we're going to talk about here, then it's actually not too bad.